Hello everyone. So let's continue solving problems together. So consider 22. So what 22 says is that if you have an integer where it is a product of distinct prime, then n is a perfect square if each Ri is even. So let n is equal to p1, r1, p2, r2, up to pk, rk, where p1 up to pk are distinct primes, and each Ri is bigger than or equal to 0, prove that n is a perfect square if and only if each Ri is even. So let's go in the backward direction. If each Ri is even, so that means we can write Ri as multiples of ki. So that means that n is equal to p1 to ki all the way to k1, all the way to pk to kk. So then that becomes p1 k1 pk k, and that is raised to the power 2. So then n is a perfect square. So let's do the forward direction. So we can just use the earlier problem that we did. So assume that n is a perfect square. So that means there exists a c in z such that c squared is p1 r1, and I'm gonna just put a bracket p2 r2 pk rk, and this is a. p1 r1 is a and the rest is b. So as an exercise, you should prove that p1 r1 P2 R2 PK RK, which is the GCD between A and B, is 1. So, no hints. So anyways, continuing where we left off, we could use the earlier problem that we proved. So let's write it down again. So what it says is, if c squared is equal to a times b, and the GCD between a and b is 1, prove that a and b are perfect squares. So using this result, we get that A and B are perfect squares. So it follows that we get that each of our i's even So I'll just leave that tiny bit of detail as an exercise. Alright, I'll see you in the next video, and I hope you guys enjoyed this one.